So we have a problem here. A simply supported beam of a length 10 meter carries a point load and UDL as is shown in figure. Draw SFD and BMD. Also find out the point of maximum bending moment and calculate the maximum bending moment. So this is the beam. Okay. So there are 2 point loads 50 kilonewton, 40 kilonewton and UDL of 10 kilonewton per meter. And total length is 10 meter. A is a pin support, D is a roller support. Okay, so in case of A there will be the two reactions, that is RA and horizontal reaction, and in case of D there is a vertical support only. So very first point of calculation is nothing but the first we have to calculate the support reaction. As I have already told you, these are the three equations of what we can say static equilibrium. Okay, so we are using summation of Fy is equal to 0, this equation, and the forces which are in upward direction are called as a positive, are considered as a positive. The forces which are in downward direction, they will be considered as negative. So as Ra is in upward direction, 50 kilonewton force is in downward direction, 40 kilonewton force is in downward direction, and UDL is also in a downward direction, and RD is in upward direction. So depending on this direction, RA minus 50 minus 50 minus 40 minus 40 plus RD is equal to 0. So we got the first equation, RA plus RD is nothing but the 130 kilonewton. Okay, now to find out the reaction at D, we have to take moment at a point A. Okay, and as it is a pin support, okay, there will be bending moment will be 0. So summation of moment at point A is equal to 0, and is considered, and the clockwise moment is considered as a positive, anti-clockwise moment is considered as negative. Okay, so now taking moment at A, 50 is rotating in a clockwise direction, so 50 multiplied by 2 and plus this is the UDL. Okay, so 10 into 4, it is nothing but 40 kilonewton load, and it will act at a center. So 2 plus 1, 2 plus 2 will be nothing but 4, so 40 into 4, and this 40 is 6 meter away from this point A. So 4 into 2, that is 4 plus 2 is nothing but 6, so 40 into 6 minus RD into 10. Okay, D point is located at a 10 meter away from point A. So like this we have calculated the moment, and it is rotating in anti-clockwise direction, so that's why it is taken as negative. So by solving this, we got RD is equal to 50 kilonewton, which is in upward direction. So we got both reaction, that is RA is 80 kilonewton and RB is 50 kilonewton. The next step is calculation of a shear force diagram. So I have already told you that how do we calculate the shear force diagram. We use this sign convention. Towards the left of the section, if the force is in upward direction, or when towards the right of a section, when force is in downward direction, it will be considered as a positive, and exactly opposite to it is the second sign convention. So now shear force at A left, if I consider the section at the left, then at the left, then at the left side of this section, okay, if I consider the section like this, then at the left, towards the left of the section, there is no any load, so shear force at A left is 0. When consider at shear force section at right side of this point A, then there is only upward reaction, that is RA is nothing but 80 kilonewton, which is in upward direction. The shear force at A right is considered to be 80 kilonewton. It is in upward direction toward the left of the section, that's why it is positive. Shear force at A right is 80 kilonewton. The shear force at B left will be same, because there is no load along this length of beam, so it will be also 80 kilonewton. Then shear force at B right. Shear force at B right, when we consider, then we have to consider this 50 kilonewton load. So that's why plus 80 minus 50 is equal to 30 kilonewton. Then shear force at C left, I am considering the section at this point, and I am going to consider all the forces in left direction. So what happens? This is plus 80 kilonewton minus 50 and minus 40. Why minus 40? 10 into 4 is nothing but a total load, that is minus 40. So it will be minus 10 kilonewton. Okay, while calculating the shear force, we do not need to consider the distances. Okay, we have to just consider the force. Now, shear force at C right, I am considering right side of this C and considering all the forces in the left side. So it will be positive 80 plus 80 minus 50 minus 40. So it will be minus 10 kilonewton. Okay, when I consider for minus 40 plus minus 40, that will be considered as minus 50 kilonewton. Okay, shear force at the C right. So I have to consider this 40 also. Okay, like this. And shear force at D left, when I consider the section at like this, that means I am not going to consider this RD. Okay, I am going to consider looking at the left side of this section. Then left side of the section, so that will be, as there is a no load, so whatever the shear force is here, that will be continue, and that will be minus 50 kilonewton. When I consider shear force at D right, I have to consider this reaction ready, and it is positive 50. So minus 50 plus 50, that comes out to be 0 kilonewton. So now this is the shear force diagram I have drawn from this calculation. Okay, shear force at A left is 0, shear force at A right is positive 80, shear force at B left is positive 80, shear force at B right is positive 30, shear force at C left is negative 10, so it is below the reference line. Shear force at C right is minus 50, so that's why like this, and shear force at D left is minus 50, and shear force at D right is again 0. Okay, now they have also told us to calculate the point of maximum bending moment. Okay, so I have already told you that whenever we are going to locate the point of maximum bending moment, that will be when the shear force is going to change its sign. When shear force changes the sign, at that point there will be the maximum bending moment. So this is the point where shear force is going to change the sign. So we need to know the location of this point from this support A. Okay, so how to do that? So I have here given the explanation to locate point of a zero shear force in span BC. BC मतलब has a span I. So along the span BC, this is the point of a zero shear force. Okay, so for that I have given this equation. Okay, up to this point I have considered all the forces in left direction. Okay, so 80 kilonewton is in upward direction, so that's why I have taken 80. 50 kilonewton is in a downward direction, so that's why I have taken is negative 80 minus 50, and minus 10 kilonewton force or load will be over this length. Okay, but we do not know the exact point. Okay, so I have considered this x, and we know that this distance is the 2 meter. So this distance will be nothing but x minus 2. Okay, and we are only considering the force, so 10 multiplied by this length, and this length is nothing but equal to x minus 2. So minus 10 into x minus 2 will give us the total load, that is equal to 0, because at this point the shear force is 0. So by solving this, we got x is equal to 5 meter. Okay, 5 meter is nothing but the distance of point of maximum bending moment point from the A. Okay, so now go for the calculation of bending moment. So we know x is 5 meter, and for calculation of this bending moment, I have given here that we have considered the sign convention. Clockwise is positive and anti-clockwise is negative if it is toward the right of a section. So these are the sign convention. So bending moment at A, as I have already told you, this is the pin support. So definitely the bending moment at A is nothing but 0. And bending moment at point D will be also 0 because it is a roller support. Then bending moment at point B. Bending moment at a point B, there are the less forces, so I will consider the left side of this. So when I consider left side of the section, if it is in clockwise direction, it is considered as a positive. So bending moment at B, there is only reaction A, that is 80 kilonewton, and the perpendicular distance is a 2 meter. So 80 multiplied by this 2 is nothing but 160 kilonewton meter is a bending moment at point B. Now bending moment at point C. When I calculate bending moment at point C, I see that there are less forces on the right side of the section. So I will consider this side. So bending moment at point C and right side of the section in anti-clockwise direction, this RD is going to rotate in anti-clockwise direction like this. So that's why it will be positive. So 50 meter is nothing but the reaction at this point RD. There is a reaction is 50 kilonewton and this is 40 kilonewton. This is 80 kilonewton. Okay, so that's why 50 into 4 is nothing but 200 kilonewton meter. Okay, so this is bending moment at point C. We know that at this point, that is at the distance of 5 meter from this A, there is a maximum bending moment. Okay, there is a maximum bending moment. So for that, what I am going to do is I am going to calculate the moment at this point. Okay, so at a distance of 5 meter from this support, at a distance of 5 meter from this support, I am going to calculate the bending moment. So this 80 is rotating in clockwise direction, so that's why it is considered as a positive, plus 80 into 5 minus this 50 kilonewton force is also rotating in anti-clockwise direction, so that's why and the 50 kilonewton force is rotating in anti-clockwise direction, so that's why it will be also negative. Okay, because at this point I am going to take the moment and it is rotating like this, so it will be considered as a negative. So minus 50 into 3 minus this 10 meter load is on 5 minus this 2, it is on 3 meter length, so that's why 10 multiplied by 3 and it will act at the center, so that's why multiplied by 1.5. So we got the moment of 205 kilonewton meter. Now how to draw the bending moment diagram is nothing but this is the reference line and I got at point C 200 kilonewton meter moment, and at point B I got 160 kilonewton meter moment. So I have plotted this point and have drawn this straight line because it will be a straight line variation, and at point X there will be maximum bending moment, that is 205 kilonewton meter. Okay, and it is inclined line, so that's why there will be the curvature like this. So this is the point of a maximum bending moment. So this is how we have to solve this problem.